All right, so there's basically two main types of problems that we'll see in this lesson, and then there'll be some applications when we get to class. We'll look at some word problems and applications, but I just want to kind of show you the nuts and bolts and the basically skills of how to do these things, and then we'll explore some extensions and applications in class. Okay. All right. Maybe at the end of the video, we'll see how long the video takes. All right. So number one here, it says complete parts A through C for each quadratic function. Find the y-intercept. Okay, so we're going to find the y-intercept, the equation of the axis of symmetry. Notice how it's the equation of the axis of symmetry, right? Because it's a line, right? So it has an equation. It's not just a value or a point. And then we want to find the x-coordinate of the vertex. Okay. All right. Then we're going to make a table of values. We'll see that table here. And we want to use this information to graph the function. Okay. All right. So let's start with the y-intercept. So here we have this quadratic, and we're actually missing, right? Usually we see ax squared plus bx plus c, but we're missing the b and the c. So if that's true, that means that they're both 0, right? We have 0x plus 0. And so c is 0. That's our y-intercept, right? And so our y-intercept is 0. So when it says find the y-intercept, it's going to be 0, comma 0. All right. Okay, the equation of the axis of symmetry. Let's do that next. So remember that the formula there is x equals negative b over 2a. All right. And so let's plug those values in. So b is 0, right? So it'll be negative 0 over 2 times a, and a is negative 2. So 0 divided by anything is 0, right? But let's just do a little math there. So yeah, so negative 0 divided by negative 4 is 0. And so our axis of symmetry is x equals 0. Okay. So it's not just 0, it's x equals 0, right? Because once again, it's a line. So it's the equation of the line that goes through 0, right, on the x-axis. All right, so the x-coordinate, that just made it pretty easy to find the x-coordinate, right? That's also going to be 0. Remember that h equals negative b over 2a. So it's the same as this, except the x-coordinate is actually a point, right? It's the coordinate of the vertex. So that's 0. Okay, so now it says make a table of values that includes the vertex. So here what I'm going to do, I have x and y, right? So I want to pick some x values. So I'm going to definitely start with the vertex. So I'm going to put that in the middle. Okay, so we usually have 5 values, so we put the vertex in the middle. And then we pick 2 points on either side. All right, and so now, a lot of times we'll pick the y-intercept, but the y-intercept is actually also 0, right? So we know this is 0, 0. So since the y-intercept is also 0, then we don't have any, like sometimes that gives you a point to pick on either side. Like if the y-intercept is different than the vertex, then we would put that here or here. But in this case, the y-intercept and the vertex are the same point. And so we're going to have to find some different points here. Okay. So since we're at 0, you can pick 1 or 2, whatever you want. Let's pick 1 and we'll go negative 1. So we want to kind of keep the same distance away. And then let's pick 3 and negative 3 just to actually, let's pick 2 and negative 2. 3, I'm just thinking of 3 squared, and then if I double it, I'll be way off the grid there. So let's do 2 and negative 2. All right, so now what I'm going to do is I'm just going to plug in these values to this function here, right? So I'm going to find f of negative 2, f of negative 1. We already know f of 0, right? F of positive 1, f of positive 2. So f of negative 1, or let's actually start with the positives, f of 2. So I'm going to have negative 2 times 2 squared And that equals positive 2 squared is 4. So it's going to be negative 2 times 4. We do exponents first, right? Negative 2 times 4 is negative 8. And so let's start plotting these points. So we have 0, 0, 2, negative 8, 1, 2, 3, 4, 5, 6, 7, 8. It's right here. So let's plug in 1. So negative 2 times 1 squared. 1 squared is 1. So negative 2 times 1 is negative 2. So 1, negative 2. It's right here. So we're starting to see that shape. And since we know the axis of symmetry is this, you can actually just mirror these points across the axis of symmetry. So we know that this is 1 unit away on that side. So we're going to have another point that's 1 unit away on this side, right, on the left. And so we're going to have that here, right? And the same thing over here. If at this point it's 2 units away, so I can go 2 units away in the other direction from the axis of symmetry. In this case, go to the left, and we can get that point there, right? So what I basically just figured out is that this is negative 2, and this is negative 8, right? So just to test it out, if I did negative 2 times negative 1 squared, I would still get positive 1 when I squared negative 1, right? So I'm still going to get negative 2 times positive 1, which is negative 2, right? Same as what we got here. Same thing here. If we do negative 2 times negative 2 squared, well, negative 2 squared, negative 2 times negative 2 is positive 4, just like we got here. And then I'm going to multiply that by negative 2, and I'll get negative 8. Okay, so that's why parabolas, you have that symmetrical nature, because when you plug in negatives and square them, you get the same thing. When you plug in negatives and square them, you get the same thing as when you plug in positives and square them. And so you have that symmetrical nature. All right, so now we're going to connect the dots. Now, once again, this isn't going to be perfect, but we know it's going to be curvy. It's not just a V, so don't draw straight lines through there. Try to draw a pretty decent looking curve. All right, so there it is. All right, so that was a downward facing one. So try to think of the pattern, because we're going to talk about that in a little bit. What's the pattern when we have a downward facing parabola? When do we have a downward facing parabola? When do we have an upward facing parabola?